like Yolanda said, in today's lesson, what we are doing is we are essentially just going to draw graphs. So that is what we have been working towards. If for those of you that have been with us for the whole course, that is where we are working towards. And so today we're finally going to start drawing some graphs. Now remember, guys, the whole point of this course is to explore and understand the different ways that we can represent relationships. Oh, sorry guys, I'm exhausted. We have discussed ways to represent relationships such as flow diagrams, tables, equations. There's a whole bunch of different ways to represent a relationship. What we're now going to get into today is the specific type of way of representing your relationship, whereby we draw a graph to represent it. Now guys, graphs are useful in a whole bunch of different scenarios, a whole bunch of different contexts. If you work for a company one day and you need to draw a graph of your profit margins or your incomes, expenses, whatever, a graph is a really useful way to visualize this information. So a graph is a visualization of a relationship and a set of variables that we're working with. Right, so we know, like when we did data handling, we have different types of graphs that we can use. It is a visual representation of a relationship. Alrighty, so we did, I don't even know what day we're on. We did on Wednesday end up drawing one graph just to sort of see what the whole situation was with drawing a graph. So shouldn't be anything too tricky or too new. However, we're just going to start slow. You guys know that if at any point you have questions, you just pop your questions on the chat. Yolanda or myself will help you. But that's how we run things. Right, now guys, remember I also said to you that if you are going to draw a graph, what's really useful is to have a table, okay? The table allows us, and I've written exactly that on the screen here, the table allows us to get our coordinate pairs, right? This is why it's useful for us to have a table. So we can get our coordinates. Now remember, a coordinate is an X and a Y value. So when we start to draw our graph, taking this X and Y value, remember what we do is we use a Cartesian plane. And I've got my Cartesian plane on the side here. We did discuss this in the last lesson, but generally speaking, in a test or exam, you will be given the Cartesian plane. It's very rare we ever expect you to draw it yourself. However, we can expect you to draw it yourself. So just remember that your Cartesian plane is essentially a number line. You need to have an even spacing between your numbers or your values. You need to draw it with a ruler. It would also help if I could count. So you can be expected to draw your own Cartesian plane. Like I say, it's not really something we expect you to do because it's a bit of a waste of time, as you can see whilst I'm trying to pull this in. But just bear in mind that we draw our graphs on a Cartesian plane so that we can represent this relationship. Okay, I'm actually going to, okay. So what we have here is a relationship given to us by the equation y equals x plus 1. So this is the relationship I now want to graph. Now remember, in order to do that, I have to consider my input values, my x values, and my output values or my y values. Those are the values I need to consider. Now, again, I've spoken to you about this before, but my advice is when you're setting up your table for yourself and you have to now select your x or your input values, select negative values, 0, and positive values. So here I can see I've got 5 input values that I want to find. So I'm going to work with -2, -1, 0, 1, and 2. We said in last week's lesson, so Wednesday's lesson, that you can pick any values for your input, like whatever you want. If you wanted to pick 10,000, by all means, go for it. Obviously, remember, you then have to plot it, so don't pick wildly big values. And we spoke about the fact that what is really going to help you is to have 3 different types of values. Negative values, 0, and then positive values. If you can pick one of each of those at least, you will draw a perfect graph. All right, now guys, remember that in order for us to draw this graph, we now need to use this rule as well as these input values, and we need to get an output value. So if we have our input value of x equals -2, what we want to do is we want to take our rule of y equals x plus 1, and we are now going to substitute in -2 in place of x in order to find our output. So -2 plus 1 is equal to -1, which means our corresponding output is -1. Now remember, what you are doing when you find this output is you're finding that coordinate or that ordered pair. So now I know that my first coordinate that I could plot is -2, -1. We do exactly the same thing with all of our other outputs. If I now have x equals -1, y is equal to -1 plus 1, we know that -1 plus 1 is actually just 0. And so again, I get my output value, and again, I get my next coordinate pair, which is -1, 0. So every time I substitute in an input value, I'm getting my output value, and I am thereby able to get my coordinate pair. So I want you guys to find the output values for A, B, and C there in the table. So I want the output value in x as 0, 1, and 2. Let's put our answers on the chat. Let's see what we come up with, and then we will draw our graph. Ooh. All right, guys, I hope all of you that were potentially struggling with audio, visual, seeing screen issues, those are all sorted. But remember, if you do at any point have a problem, you just message Yolanda or myself, and we will help you out. Right, so guys, I've got a question here of must we choose the x values in the test? The way this will be asked is in two ways. Either yes, you need to choose your x values. So if you get no table and you now need to draw a graph and you want to use a table to help you, you will choose those values. The second way we could ask it is we could actually give you the table with the values in, and then you don't need to worry about choosing your own values. So it depends on what you've been given. If you've been given a table with values, you use those. If not, you can pick your own. Nice, grades, well done. Okay, so our output values here would be 1, 2, and 3. We take the x value that we have and we just add 1. Right, so now what we're able to do is we are able to plot our graph. Now remember, we've got all of our coordinate pairs as a result of this. So the next one would be 0, 1, 1, 2, and 2, 3. So we've got these coordinate pairs we can now plot. So -2, -1, we go to -2 on the x, down to -1 on the y. There's my first coordinate. -2, -1. My next coordinate was -1, 0. So I go to -1 on the x, 0 on the y, which is actually on the y-axis, on the x-axis, sorry. And we plot our coordinate -1, 0. Our next coordinate, 0, 1, on the y-axis now. Then we've got 1, 2, and then we have 2, 3. Now, hopefully what you're seeing as I plot these points is they are starting to form a shape, or they're starting to form a graph. And so now we are able to draw in our graph. So we take our ruler, very importantly, we use a ruler, and we join the dots. Okay, a little bit better than what I'm doing. As you can see, I've got an arrow on either side of the end of my graph. This tells us that the graph technically goes on for infinity. We just obviously can't draw to infinity. The other thing I hope that you notice is that we extend our line to the end of the Cartesian plane. Right, reason for this is when you draw your graph, I don't want to see some tiny little graphs. I don't want to see a line that looks like that, right? Yes, that is technically a graph, but I want to see the relationship over this extension. We always extend our line as far as we can on our Cartesian plane. We put arrows on each end to show that it does go to infinity. And there we have our graph. Right, so guys, if we did have a graph like this would show essentially the relationship between X and Y. And because this graph is increasing from left to right, what we have here is an increasing relationship. Right, and what that means is basically as X increases, so as your input value increases, your output value your output value increases. Yes, you do have to draw the graph. If you've been told to draw the graph, you do have to. Right, so yes, you have to draw the line. If you've been asked to draw a graph, you have to draw the line. Right, I've got a question here, so please listen up. It was a direct message, so I'm not going to say your name, but I hope you're listening. I don't understand how we calculate A, B, and C. Right, I'm not going to do all of them, but I want you to listen to how we do A. So A, we have got an X value of 0. I gave that to you, right? That was given to you. You have that information. So what we do is we substitute X equals 0 into our equation that we were given. That equation was Y equals X plus 1. So whenever I see an X, I'm going to replace that with a 0. So Y equals 0 plus 1. And we know that 0 plus 1 is 1. That is how I got my value for A. We do exactly the same thing for B and C. So quickly for B, now my X value is, is 1. Okay, grade 8. I'm explaining the entire question right now. So those of you who are saying, I'm stuck, I don't understand, you should be listening to my explanation right now because I'm explaining it, right? Now, if you're still stuck, then absolutely ask the question. But I'm going through how we've calculated these outputs and how we've now plotted them. We have technically done all of this work already. So remember, I've said to you, we've done number patterns, we have done equations, we have done the Cartesian plane. So we have actually done everything on the screen right now. So I really need you guys to listen. I really need you guys to focus. And if you are still not able to do that, then I think perhaps maybe you need to take a second and then you can watch this recording in your own time where you are then able to focus completely. Right, so those of you that are saying you're lost or you don't understand where something's come from, you need to be listening because I'm actually explaining it right now. So as I was saying, what's happening here is we've got X equals 1. Again, I have given that information to you. That was in the table. I gave it to you. And we are going to substitute into exactly the same equation. This is the rule that we are using. So Y equals X plus 1. I'm going to substitute in my 1. So I've got 1 plus 1. And we know that 1 plus 1 is 2. That's how I got my output value of 2. Exactly the same thing is going to happen for my X equals 2 value. I'm going to substitute that in. So 2 plus 1, which gives us 3. That's how I got my output value of 3. All right, so this is how we are getting these values here. Once we have X and Y, remember what you now have is your coordinates. So remember, coordinate, as I've written up here, let's choose a different color, is an XY value. That's essentially what I've written down. X and then Y, X and then Y, X and then Y, etc., etc. Once I have those values, I can now plot them onto my Cartesian plane. So this point, -2, 1, I've plotted on my Cartesian plane. How did I plot it? Well, I went to -2 on the X, I went to 1 on the Y, and essentially where they meet up, I have plotted my point. And I do that for every single point that I have found. in order to get this straight line. Okay, so Gabriella, I hear you. You only joined 2 weeks ago. However, this is probably something that you have already done at school, at least some of it. But if it hasn't, that's also okay. We have also been doing this for 2 weeks. So all of those videos are online. You can go and re-watch them. We have been chatting about this a fair amount. Okay. There was another question somewhere that I just want to make sure of. Okay, so Tebogo, your line doesn't always have to be straight. We will discuss some types of graphs. Sorry, stop it. We will, my cats, I wasn't saying you, stop it. We will discuss some types of graphs where they don't create straight lines, but you will see in the equation that it won't be a straight line. So whenever you have an equation where there's just an x coordinate, so it could be 2x, 3x, or half x, but there's no like x squared or something to the power of x. If it's just a normal x, it's going to be a straight line. Like I say, we will chat about some graphs that aren't going to be straight lines that we definitely can expect you to draw. And then I'll point out how the equation is different and how you can sort of identify it from the equation. Okay. Right, so those of you who said I'm lost, those of you who said I don't understand how we calculate A, B, and C, I hope that we now know how to calculate them. I hope that we now understand a little bit about what's going on. Please also remember, grade 8, this is the first question. Okay, we're going to do a lot more and hopefully it'll make more sense as we start to practice it. But exactly like Yolanda has said, there are videos on this. So go and watch the videos. There's videos on number patterns, videos on the Cartesian plane. There's videos on this stuff. So please do go and watch it. It just means that you need to maybe take an hour or two out of your time, one afternoon on the weekend, and just make sure that you catch up what you need to. Right, so please let's take a screenshot of this first example. Like I say, we're going to do lots of examples today, hopefully, and hopefully as we do more, it makes more sense. Remember, guys, this is the first time we're properly drawing a graph. It's okay if it doesn't make sense initially. We keep practicing, we keep going, we keep asking questions. While you're taking screenshots, if anyone still has any questions, then we need to either put it on the chat or we need to raise our hand at this point. Otherwise, like I say, after screenshots, we're going to move and have a look at another example. So any questions, please ask. You may raise your hand at this point if you want. Nelson? Nelson, are you there? Okay, Nelson, I think you might be connected to the incorrect audio option. So just double check that because you are unmuted, but I'm not hearing anything from your side. Okay, Nelson, I can't hear anything from you. Double check your audio connection. Put your question in the chat so long and we can always try again later, but just double check your audio connection because there's no sound coming through from your side. Right, guys, so let's have a look at another one. Right, again, we have our equation that we've been given. So here our equation is y equals 3x minus 2. Now, again, we can see that we have a rule. We can see that we need to apply this rule in order to get the graph. If you can't see the screen, log out and log back in again, please. If you still can't see the screen, you need to unpin and repin my screen. If you still can't see the screen, then please message Yolanda or myself and we'll help you further. All right, so guys, okay, we'll deal with this in a second. Once again, we have our table that's going to help us. We've got our x and our y values, and we're just going to stick with the same values, -2, -1, 0, 1, and 2. All right. So as soon as we get a rule, as soon as we get our table sorted, we can now start to substitute. So remember, we're substituting in order to get our X and our Y values. Panic. And we are able to then get our coordinate pairs that we are going to plot. Okay, so Nelson, I did actually just explain this. The line doesn't necessarily always have to be straight. And as I said, we will have a look at a couple examples where the line or the graph that we draw isn't going to be a straight line. Right now, though, what we're focusing on is straight lines. Like I said, whenever you just have an X term, so it's not X squared, it's not to the power of X. If it's just an X term, so an X term, so nothing fancy, then it's going to be a straight line. Okay, so that's what I said earlier, and we will look at some examples where there aren't straight lines and see how the equation then differs. Okay, so grade 8, what we want to do now is we want to go and find our output values. I'm going to do the first one with you. You are then going to do the next couple by yourselves. Right, so this first one, we take the X value that we have been given, so the fact that X is equal to -2, and we go and substitute that value into our equation. Now, our equation that we were given is y equals 3x minus 2. I know that because I gave it to you right at the start there. And we now replace the X value with a -2. So we're going to have 3 times -2 minus 2. Whoops. And now all we need to do is we need to solve for y. So y equals +3 times -2 is -6 minus 2. Now, importantly, it's -6. So we're already here. If you look at this number line, we're already at -6. We want to subtract another 2. So we are now ending up with a y value of -8. And so that therefore tells me that my output value is -8 when x is -2. Now remember, what this gives me is my coordinate pair, -2, -8. So what I want you guys to try, you're basically doing exactly the same thing. You're just looking at what your input values are, so -1, 0, 1, and 2. I want you to tell me what those output values are. Again, guys, we've been doing this for the past 2 weeks. That's how long this course has been going. We have been doing substitution into our equation for most of those 2 weeks. So this bit, nothing too new, the drawing the graphs, definitely the newer stuff. So we're getting into it. Okay, so on the chat, I want to see your answers for A, B, C, and D. You do exactly the same thing that I just did with the -2, but now with your other input values. Okay, I'm not seeing any answers next to those letters, so just make sure you are giving the answers, please. There's another one that also just sent ABC. Just remember to put your numbers or your answers there for me as well, please. So just remember you're substituting, so you're replacing X with the numbers I've given you in the table, and you're finding your output. Give you another minute or so, and then we'll have a look. Bye-bye. Good, grade 8. Keep those answers coming. Another few seconds. Nice. Alrighty, good, guys. Well done. All right, so if we have a look at B, I'm going to do the substitution just so we're all clear. We're going to substitute in x equals -1. So y equals 3 times -1 minus 2. Positive 3 times -1 is -3 minus 2, which therefore gives us -5. So this next output value that we have here is -5. We're going to do the same thing with the 0. So when I say the same thing, what I mean is instead of -1, we're now going to substitute in 0 into our equation, which means we've got 3 times 0, which is 0, minus 2 is -2. Next one, we've got x equals 1, so 3 times 1, which is 3, minus 2, which is 1. And D, 2 times 3 is 6, minus 2 is 4. So we get all of our output values just through substitution. Okay, so that's really important to remember the substitution. We now have all of our coordinate pairs that we can now go and plot onto my Cartesian plane. And remember, guys, because this is just a normal x term, it's not x squared, it's not to the power of x, it's just a plain old x term, we should get a straight line. When you start to plot your points, you will start to see the shape. So it's not going to be unclear to you. You're going to see that your dots start to form a straight line. And so you will be able to see that it should be a straight line graph if you're in doubt at all. Right, so let's plot our points. We have got -2, -8. Obviously, I've made choices here and not gone all the way down to -8 on my y. So let's just fix that. Whoops. Whoops. -6, -7, -8. Bagheera, stop it. My cats have joined me for this lesson and they are chaos. Alrighty. So -2 on the x, all the way down to -8 on my y. So there's my first coordinate. Second coordinate was -1, -5. So -1 on the x, all the way down to -5 on the y. Plot my point. 0, -2. So 0, remember, is at the origin. 0 down to -2 on the y. 1, 1, so 1 on the x up to 1 on the y. And finally 2, 4, so 2 on the x up to 4 on the y, and we get our coordinates. Now guys, you can see that through the dots I've plotted, or through the points I've plotted, I can see that they're forming a straight line. Okay, just by how the sort of shape is going, I can see that I'm going to get a straight line. So I get my ruler, draw my straight line, so join all my dots together. I've done this very well, there we go. Join all of my dots together, and I am getting my straight line graph. Just trying to make this bit there. Right. There we go. So I've joined my dots. I knew it was a straight line because it was just a normal old x term, nothing too fancy, not x squared, not x cubed, not x to the power of x, just an x term. And so I've got my straight line. Again, even if I didn't know that, just based on where I've drawn my dots or where I've plotted my points, I can see that they're going up in a straight line, so I can see how I should join them. All right, so guys, when we plot a graph or when we draw a graph, it's really important that we get our coordinates, and that may be from a table. And then when we plot our points, we're going to get that relationship visually shown for us. Right, so any questions, let's raise our hands now, or you're welcome to put them in the chat, completely up to you, whatever you would prefer. Any questions, now is the time to ask me. Otherwise, again, we're going to do another example, And we're just going to keep practicing until hopefully this starts to be a bit more comfortable for us. Okay, so those people who are maybe feeling a bit unsure, hopefully we are feeling a little bit better now. But obviously, guys, just keep asking questions if you're not 100% sure. Lindo?
Hi, ma'am.
Hi.
Ma'am, I heard the part where you're explaining for the last one, but I wanted to be sure. Since I saw you counting down on the table, how many steps did you know that you go down to 5, from -1 to 5?
Okay, so I just want to make sure we're talking about this coordinate over here.
Yes, ma'am.
Okay, so you asked me how did I know that it was -5?
Yes.
All right, so remember that came from me essentially substituting. So what I did was I took my -1 and I substituted it into my equation. Once I did that, I got my output of -5. So that is how I knew that I had to go down to -5 on my y-axis.
Oh, thank you, ma'am.
Okay, so it's through my substitution. Good. I know we've done this many times before. Lagan, I'm sure, but correct me.
Ma'am?
Yes.
Oh, ma'am, I was gonna ask, ma'am, ma'am, I understand, ma'am, like the working out stuff, ma'am, but I'm not really sure about the negative stuff on the plotting down, ma'am.
Okay, so how to plot these ones that have negative signs in them?
Yes, ma'am.
Okay, so guys, I'm gonna do so I wouldn't plot it like this normally. Once you get more comfortable with it, that's fine. But let's go and just chat about how we plot one of these points. So Legan, give me a point that you would like me to explain. Any of these points, which one would you like me to explain?
-8, ma'am.
Okay, so guys, we're gonna have a look at this first coordinate here. So what you do, what you need to remember is that it's x first and then y. So what we do is we find the -2 on my x coordinate, because that was the x value, and then we find the -8 on my y-axis. Now remember, your horizontal axis, I've got so much going on here, is your x-axis, your vertical axis, the up-down axis is your y-axis. So that's how I know where to find which value. What we then do to plot it is essentially we draw a line vertically all the way down, a line horizontally across, and where they meet each other, that is where I plot my point. Okay, so that is how I know exactly where that point needs to be. Again, why did I know it was -8? Well, that was through my substitution. So I'm getting this value, so all of these y values, I'm getting through my substitution. When I then go and plot it, x down, y across, where they meet, that's where I plot my point. Does that answer your question?
Yes, ma'am. I understand now, ma'am. Thank you.
Good. Well done. Alrighty. Okay. Couple of questions on the chat. Siam Tanda, yes, you can put, okay, when you say the dots on the other side, I'm understanding it as in I could rather put this as 2, 4 on the other side of the line. If that's not what you mean, please correct me. But the dots have to be where they be. The labels could be on either side of the line. That's absolutely fine. So Siam Tanda, if that's not what you meant, please correct me. Pretty, it's always been dots. So when we plot a coordinate on our Cartesian plane, we always use a dot. The only time we wouldn't use a dot is if we were maybe drawing like a scatter plot in data handling, and then we maybe are plotting a whole bunch of different things. But whenever we draw on our Cartesian plane, it is always a dot. I can't tell you why it's a dot. Someone just decided it needs to be a dot, probably because it's quite a small point that we draw rather than like a cross or something. Small, it's concise, it's not like in the way, and we can work with it from there. Right, again, guys, I've said this already, dots can become more of a shape. We will discuss those graphs when we get there. Right now, we are just doing straight lines. Okay, so I've said this a few times, I'm not answering that question again. Pretty, I don't understand. What do you mean? Why do we need to draw the N? I don't know what N you mean. So if you can just help me out there, I can then explain it. Amahle, you can do it however you want, as long as at the end of the day you get a graph, I'm happy. Abungile, it's not a must to put the labels. I'm just putting them there so we can see where the coordinates are. You only have to put the labels on if they ask you to label the graph, then you need to do it. But if you're just drawing a graph, you don't have to. So just read the instructions in your question. That'll tell you what you need to do. Okay, now again, guys, I am not answering a question again that asks, what happens if the dots become a shape? Is it always a straight line? I've now done this about 4 times. So you now need to wait. We will get there. If we don't get there today, we'll get there on Wednesday. I've explained it multiple times now. We need to listen. Okay, Pretty. Yes, you have to draw the number line. Sorry, I'm not there. So you have to draw, and when we say the number line, we mean the X and the Y axis, right? Because without the X and the Y axis, we don't have a Cartesian plane. So yes, you have to draw the number line. Like I said at the start of the lesson, most of the time in a test or exam, we do give you the Cartesian plane. So you don't actually have to draw the X and the Y by yourself. We will give that to you. But if we don't, then yes, technically you do have to. Right, Gabriella, exactly. Well done. So in each quadrant, your X and Y has different values. So we actually label these quadrant 1, quadrant 2, we go anti-clockwise, quadrant 3, and then quadrant 4. So those are our quadrants. Quadrant 1, everything is positive. Quadrant 2, X is negative. I'm trying to do this with the mouse, I don't know why. Y is positive. Quadrant 3, X is negative and Y is negative. And then quadrant 4, X is now positive again, but Y is negative. Good observation. Well done. All right, guys. So I hope you've taken screenshots. I hope that I don't think I've missed any questions. I have scrolled through the chat to make sure that I've got everyone's questions. Remember, just keep asking those questions. Let's have a look at another one. I hope we've all taken a screenshot. I will wait for 20 seconds and then we're going to move. Okay, so Simtanda, I hope I answered your question. Just let me know if for whatever reason I've missed it. But I think the yeah means we got it. Cool, Gabriella, well done. Okay, Simtanda, awesome, well done. Okay, guys, so let's have a look at another one. So exactly the same thing, like nothing about our process is changing. We're doing exactly the same thing. We've got a rule. We're going to substitute our input values into the rule, and we're going to find some outputs. So our rule this time is y is equal to, oh golly, minus 2x plus 1. Remember, we are given a rule. We use that rule to find our outputs. So our inputs, our outputs. Here are my input values. We are going to find the output values. Again, I will do the first one with you. You're going to do the next 4. So you're going to do these last 4. I'm going to do the first one with you. So this is my input value, x equals negative 2. We're going to substitute this into our equation of y equals minus 2x plus 1. So wherever I see an x, I'm going to substitute in the negative 2. Y equals negative 2 times that negative 2 plus 1. We know that negative 2 times negative 2 is a positive 4 plus 1. And so we get our output value of 5. All right, so just be careful. When you've got a negative, always double, and then I wrote a negative 5. Always double check your signs when you're multiplying. But exactly the same thing as what we have been doing. We substitute our value for x and we find our output. Okay, so exactly like Leno's put there on the chat, please can you find for me A, B, C, and D? Exactly the same thing as what we've been doing, grade 8. Nothing's changed. So substitute, find your output values. And then if you really want to, if you're ready to draw a graph and you're feeling confident, you are absolutely more than welcome to now take those coordinate pairs and draw the graph. Okay, guys, let's try and use the A, B, C, and D that I've put there for the answers. Okay, keep them coming. Okay, guys, good. So let's have a look at this next one here. So we've got -1. We're going to substitute in. So x is -1. We're going to sub that in. Y equals -2 times -1 plus 1. -2 times -1 is +2 plus 1. And so y in this case is equal to 3. Remember, you also can just use a calculator for the substitution. You don't have to write it out unless you are asked to show it. But remember, when you substitute, always remember to type in your brackets. Right, if we look at the 0, y is equal to -2 times 0 plus 1. -2 times 0 is 0 plus 1. So y here is 1. If we now do the 1, -2 times 1 is -2, plus 1 is -1. -2 times +2, -4, plus 1 is -3. Okay, so again, we've plotted, or rather we've gotten our x and our y coordinates, and now we can plot our points. Let's just write down our coordinate pairs. It's quite useful to have those. So -2, 5. Remember, always x first, then y. -1, 3, 0, 1, 1, -1, 2, -3. Always x first, then y. That's never going to change. Right, so now we plot our points. We go to -2 on the x-axis, so over here. We go up to 5 on the y-axis. If you drew in lines where they meet, you would now plot your point. -2, 5. Again, guys, you don't have to add the labels for the coordinates. I'm just labeling them so that we know which is which. Next is -1, 3, 0, 1. Okay, apparently it's just going to disappear, so that's fine. Then we've got 1, -1. So here's 1 on the x, there's -1 on the y. Where they meet, plot our point. And our last point, 2, -3. So again, if I look at my dots, if I look at my points, I can see they're forming a straight line. This time, however, we can see that it's a decreasing line, which apparently I can't draw very well, so I will sort that out. Okay. There's my decreasing line. I know it's decreasing because it's going down from left to right. This shows a decreasing relationship, unlike the last two that we've seen, which was increasing. And guys, you can also tell it's decreasing by looking at the output values. We went from 5 down to 3, down to 1, down to -1. Those Y values are decreasing, they're going down. And we know that the line we draw should represent the relationship. That's the whole point of our graph. Alrighty, so let's take our screenshot.